Hi, this is Antonia. I'm here with the Mackendale group at the University of Victoria, and today I'll be talking a little bit about the PSI technique. So PSI stands for Pressurized Sample Infusion into a mass spectrometer. In this case, we're using a TQD electrospray ionization mass spectrometer. And the way to do so is to apply a slight overpressure of an inert gas to your reaction flask. In this case, I'm using a 25 ml pear Schlenk flask to push your solution through a capillary tubing. Here I'm using peak tubing into the source of your mass spectrometer. This is a great technique as it allows for real-time in situ analysis of your reaction, and it also allows you to change variables such as the temperature by submerging your flask in an oil bath, and it allows you to add reactant or catalyst to your solution. This is usually done via a syringe injection straight through the septum. And another advantage of this technique is that it can be done in an air and moisture-free environment in a Schlenk flask that was purged by an inert gas. In this case, I was using nitrogen, and it is now filled with nitrogen gas, closed and protected by the septum. So, to do this run, and here I have a solvent and a ligand that I wish to analyze in our mass spectrometer. So for this, I have prepared my flask. I have attached it to a clamp. I am using a hot plate to stir my solution. And now the first thing I'm going to do is turn on the gas. So for this, I will go to the cylinder and I will turn on the main valve. I'll make sure that this is open. Then I'm going to turn on the output valve. We have found that at around 5 psi, the pressure is at its optimal. It usually has a flow rate of about 10 microliters per minute at 5 psi. And you'll notice that I am just letting this run for a bit. This is to push any oxygen that is in the line out first before introducing it to your oxygen-free flask. So I'm just letting this run. You can check if the gas is flowing by just pushing on it. You can hear it, but you can also watch the pressure gauge rise slightly. And so the next thing I'm going to do is just purge this outlet here to make sure any oxygen in this tubing is pushed out. And then I will apply my tubing. Make sure it is nice and tight so that there are no leaks. And while you do so, always ensure that this valve is closed so you're not introducing oxygen into your flask if you are dealing with air-sensitive materials, as I am here currently. So now that I am sure that everything is connected tightly and my gas is running, I will open the valve, ensure that it is running into my flask. And then I will connect my tubing. So first I insert this into the source. Make sure it is centered and tight. I always like to give it a little tug to make sure it is secure. And then you insert the tubing into the septum. This can be a little bit tricky as it is quite tight, but to do so you can first poke it with a clean needle to create a hole that you can push your tubing through. In this case, I sparged my flask, which means I have already created a hole right in the middle here. So lining it and then applying force and pushing that straight through. Now when inserting your tubing, you want to make sure it is inside of your flask and submerged in your solution, but also making sure that you are not hitting the stir bar, which might disturb the injection rate. So ensuring that this is inside of the flask, everything is connected tightly, my gas is on, my stirring is on in this case, you can proceed as normal with your mass spectrometry.